Hello everyone. In this video, we are going to learn about single inheritance in C++, one of the fundamental concepts of object-oriented programming. Inheritance is an important feature of C++ because it allows us to create a new class from an existing class. The new class can reuse the data and functions of the existing class and can also add its own features. So, by the end of this video, you will understand what inheritance is, what single inheritance means, how to declare it, how access specifier works, how constructors and destructors behave, how inheritance supports polymorphism. So, starting with what is inheritance, let's begin with this concept. Inheritance is a mechanism by which one class acquires the members of another class. The members can include data members and member functions. The class from which we inherit is called the base class, or sometimes called as parent or superclass. The class that inherits from it is called as derived class, or it may be called as child class or subclass even. For example, consider this relationship between animal and dog. A dog is an animal. So animal class may contain common behaviors such as eat. The dog class can inherit its behavior and can additionally define its own behaviors. Okay. For example, it can be bark. This represents is a relationship. This represents is a relationship. Inheritance is useful for mainly for three reasons. One is code reuse. We can define common functionality once in the base class and reuse it in the derived class. Second is extensibility. The derived classes can add new behavior without modifying the existing base class. Third is hierarchy. Inheritance allows us to represent real-world relationships clearly in our programs. So now again, what is single inheritance? So let's start this term, single inheritance. In single inheritance, one derived class inherits from exactly one base class. So the structure is very simple. One base class leads to one derived class. For example, suppose we have a class called vehicle. We can also create another class called car that inherits vehicle. Here, vehicle is a base class and car is the derived class. This creates a simple linear inheritance relationship. So, starting with the syntax of single inheritance, we first define our base class. For example, class base. Inside this class, we can define data members and functions. Then we can define derived class using the following form: class derived public base. Here, the colon has to come here. So the colon indicates inheritance. The word public is an access specifier for inheritance, and base is a name of the class from which derived inherits. So we read it as class derived public base. We can understand it as create a class called derived that publicly inherits from base class. Here is a simple example. Let's now see a simple program. We create a class called animal. Inside the animal, we define function called eat. The function displays I can eat. Next, we create a class dog that inherits animal. Inside the dog, we define another function called bark that displays I can bark. Even though eat function is defined inside animal, we can also call this bark function also. So the output will be I can eat, I can bark. This is the basic idea of inheritance. The dog object is able to use the inherited functionality from animal as well as its own functionality. So the next comes the access specifiers in inheritance. So now this is an important topic. C++ provides three inheritance models. One is public, private, and protected. So public, the inheritance model determines how public protected members of the base class are treated inside the derived classes. One important rule to be remembered here is private members of the base class cannot be directly accessed by the derived class regardless of the inheritance mode. So in public inheritance, public members remains public and protected members remain protected. Here, for example, class derived public base. If the base class contains public variable x and protected variable y, both can be accessed appropriately by the derived class. Public member can also be accessed from outside the class through the derived object. This is the most common form of inheritance. So in protected inheritance, public and protected members of the base class becomes protected in the derived class. So in private inheritance, public and protected members inherited from the base class becomes private within the derived class. Here are the examples. This is the access specifiers at a glance. Next comes the constructors and destructors. Starting with the constructors, when an object of the derived class is created, the base class constructor executes first. After the base part of the object is constructed, the derived class constructor executes. For example, suppose base has a constructor that prints base constructor and derived has a constructor that prints derived constructor. When we create a derived object, the output will be base constructor followed by the derived constructor. So remember, construction takes place from base to derived. The base class must be initialized before the derived class can be constructed. And then something about passing arguments to the base constructor. Suppose base has base of int n and derived class is also defined. The base is a part is called as member initializer. It passes the values from the derived constructor to the base constructor. So next comes the destructors. The order is reversed when the object is destroyed. So base first, then derived. So during construction, it is base first, then derived. During destruction, it is derived first and then base. So accessing the inherited members, a derived class can use inherited members one according to their accessibility. For example, suppose the account has protected data member called balance. A class called savings can inherit from the account. Inside savings, we can directly access the inherited balance. Next comes function overriding. So now we'll discuss what happens when both base class and derived class have functions with the same name. Suppose the shape contains draw and the circle also defines draw. We create circle object and called c.draw. In such case, the circle version is selected. So next, it's about virtual functions and polymorphism. Now we come across one of the most powerful application of inheritance, that's runtime polymorphism. So consider base class pointer shape P, and suppose it points to the circle object. If the draw function in shape is not virtual, the function selection is based on the pointer type. So this is called as static building. But if we declare the function as virtual void draw, something like this, then C++ performs a dynamic binding. So these are two types of binding: static binding and dynamic binding. Next comes the pure virtual class and abstract classes. So C++ allows us to create abstract base classes. Pure virtual class is declared by assigning 0, which is displayed here. So some of the common things to be discussed is we have to be very careful with non-virtual destructors, and second is object slicing. If a derived object is assigned to the base object by value, only the base portion is copied. We have to have these things in mind. And finally, do not overuse inheritance. Inheritance should represent genuine is a relationship. If the relationship is not truly is a composition, maybe better design choice can be opted. So to conclude, single inheritance means one derived class inherits from exactly one base class. The base class provides common members, while derived class can reuse those members and add its own functionality. Thank you. See you in the next session.